perception of color is a pervasive part of our visual experience. It can influence our moods, affect how we interpret things about the world, and even carry symbolic meaning. But what exactly explains our experience of color? A number of theories have emerged to explain this phenomenon, and one of the earliest and best known was the Trichromatic Theory. Renowned researchers Thomas Young and Hermann von Helmholtz contributed to the trichromatic theory of color vision. The theory began when Thomas Young proposed that color vision results from the actions of 3 different receptors. As early as 1802, Young suggested that the eye contained different photoreceptor cells that were sensitive to different wavelengths of light in the visible spectrum. It was later, in the mid-1800s, that researcher Hermann von Helmholtz expanded upon Young's original theory and suggested that the cone receptors of the eye were either short wavelength, medium wavelength, or long wavelength. The short wavelength cone receptors are sensitive to blue wavelengths of visible light. Cone receptors that are sensitive to medium wavelengths experience the green color, and long wavelengths experience red color. He also proposed that it was the strength of the signals detected by the receptor cells that determined how the brains interpreted the colors in the environment. Helmholtz discovered that people with normal vision need 3 wavelengths of light to create different colors through a series of experiments. Helmholtz used color matching experiments where participants would alter the amounts of 3 different wavelengths of light to match a test color. Participants could not match the colors if they used only 2 wavelengths, but they could match any color in the spectrum if all 3 were used. The theory became known as Young-Helmholtz theory of color vision. The identification of the 3 receptors responsible for color vision did not occur until more than 70 years later, after the proposal of the theory of trichromatic vision. Researchers discovered that cone pigments have very different levels of absorption. Cones are receptors located in the retina, and they are responsible for the vision of both color and detail. The cone receptors differ in absorption amounts due to the amount of opsin amino acids in the receptor. There are 3 different cone receptors: short wavelength cone receptors that give us the perception of blue, middle wavelength cone receptors, which gives us the perception of green, and long wavelength cone receptors, which gives us the perception of the color red. The perception of color by the brain requires input from at least 2 different types of cones. The brain must interpret information about both the wavelength and the intensity of the incoming stimulation. By comparing the input from each cone that has been stimulated, the brain can interpret the color of the source of that stimulation. In the past, the trichromatic theory was often presented as competing with the opponent process theory for dominance in explaining color vision. Today, it is believed that both theories can be used to explain how the color vision system operates, and that each theory applies to a different level of the visual process. To sum it up, opponent process theory explains color vision perception at the neural level, whereas the trichromatic theory of color vision explains color vision at the receptor level in the retina. According to the trichromatic theory of color vision, also known as the Young-Helmholtz theory of color vision, there are 3 receptors in the retina that are responsible for the perception of color. One receptor is sensitive to the color green, another to the color blue, and the third to the color red. The combinations of these 3 colors produce all of the colors that we are capable of perceiving. Researchers suggest that people are able to distinguish between as many as 7 million different colors. Photoreceptors also tend to have different sensitivity levels. Blue receptors are the most sensitive, and the least sensitive are red receptors. The ability to perceive color requires an interaction between at least 2 types of photoreceptors. These 3 colors can then be combined to form any visible color in the spectrum. Color vision and perception is a complex process that involves the eyes and brain. The trichromatic theory explains one part of this process, focusing on the photoreceptors in the eye that then send signals to the brain. Learning more about this aspect of color vision is an important part of understanding how we perceive things about the world that make up our visual experience. Thank you for watching.